Today I'll be walking you through an end-to-end AI voice assistance pipeline. Let's dive into the steps. Step 1. Transcribing speech from an audio file into text. We begin by installing the necessary libraries: librosa, PyDub, WebWorkVAD, and the Whisper library. These libraries help us process audio and perform voice activity detection and transcription. We import essential libraries like WebWorkVAD for voice activity detection, VAD, audio segment from PyDub for audio processing, and Whisper, which is a powerful speech recognition model by OpenAI. The first function, apply_VAD, applies VAD to remove non-speech portions of the audio to ensure only relevant speech is processed. We split the audio into frames and filter them to keep only voiced frames. The second function, preprocess_audio, loads an audio file, converts it to a standard format, and applies VAD. It ensures that the audio is in a consistent format for transcription, typically mono and sampled at 16 kHz. Next, save_temp_audio saves the preprocessed audio data to a temporary file that Whisper can read. Finally, transcribe_audio uses the Whisper model to transcribe the processed audio into text. We load the base Whisper model, transcribe the speech, and return the text transcription. Step 2. Generating a response using an LLM. Moving to the next step, we generate responses using a language model. First, we install required libraries like LangChain for handling LLMs and laumacpp Python, which lets us load llama models. We connect Google Drive to access our model. Once that is done, we import laumacpp from LangChain to load the Llama 2 model. In this case, we load a specific quantized Llama 2 model from Google Drive. The model settings include parameters like temperature, the number of GPU layers, and the batch size for inference. Next, we set up a text processing template for the Llama 2 model. This template defines how the model responds to input prompts, in this case, answering user queries with concise responses. The process_text_input function processes the transcribed text input by feeding it into the Llama 2 model and returning a generated response. Step 3. Converting text responses back into speech. Now that we have a response, we need to convert it back into speech. To do this, we use EdgeTTS, a text-to-speech library, and install it along with Asyncio for handling asynchronous tasks. We import the necessary libraries and define an asynchronous function text_to_speech, which converts the generated text into speech using Microsoft's EdgeTTS service and saves the output as an audio file. We also define a wrapper function, text_to_speech_wrapper, which synchronizes the asynchronous text-to-speech function for easier integration into the pipeline. Step 4. Creating a pipeline to connect the steps. In this step, we combine everything into a complete pipeline. The pipeline function handles the entire process. First, it transcribes the input audio by calling the VAD, preprocessing, and Whisper transcription functions. Then, it generates a response by passing the transcription to the Llama 2 model. Finally, it converts the model's response back into speech using the EdgeTTS function. The pipeline returns both the transcribed text and the final audio file. Step 5. Gradio interface. Finally, we integrate everything into an interactive user interface using Gradio. We install Gradio and import it into our script. The function Gradio_interface calls the pipeline function and returns the transcription, the generated response, and the audio file with a synthesized speech. We define and launched a Gradio interface, allowing users to upload an audio file, process it, and receive both the text transcription and the spoken response. The app provides a seamless user experience and showcases the power of combining AI with voice interaction.
Abdul Kalam was a former Indian politician and scientist who served as the 11th President of India from 2002 to 2007. He was born on October 15, 1931, in Rameswaram, Tamil Nadu, India.